Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello future engineers, here is another video in calculus in sketching graphs of functions. I hope that you will learn new things here. If you want to anticipate the solutions to this problem, you may do so by pausing the video if you want. So how is the graph of y equals t sine x related to the graph of y equals sine x? Sketch the graph of y equals 3 sine x. Then for the second part, how is the graph of y equals 2 plus square root of x related to the graph of y equals square root of x? Use your answer to sketch the graph of y equals 2 plus square root of x. Of course, the relationship is that the original graph y equals sine x is stretched 3 units vertically. So it is just stretched 3 units vertically. So if you have our graph of sine x, you should familiar with the graph of sine x. Sine of 0, 0. Sine of pi over 2 is 1. Sine of negative pi over 2 is negative 1. Sine of pi is 0. Sine of negative pi is 0. So the graph looks like this for sine. Then all you have to do is stretch this vertically so that the maximum value reaches 3 and the minimum value reaches negative 3. So it is related, and the graph is stretched vertically 3 units upward and 3 units downward, both, so that the maximum value is 3, the minimum value is also negative 3, as shown in this figure, but the graduation is the same, like that. So that's red graph is y equals 3 sine of x. Or in other words, the graph is stretched vertically uh, by 6 units. 6 units. Total of, sorry, 3 units only above the x-axis and 3 units below the x-axis. How is the graph of y equals 2 plus square root of x related to the graph of y equals square root of x? The graph of square root of x, we sketch this graph, open upper branch of the parabola that is open to the right. So it is related to y equals 2 plus square root of x by the fact that that graph of y equals square root of x is shifted 2 units upward, vertically upward. So if we have the original graph of y equals square root of x, which begins with 0, open to the right, then all you have to do is shift this vertically up so that the vertex is now at 0, 2, and we have the same length of curve, same shape of curve. So that's y equals square root of x, and this is y equals 2 plus square root of x, that red graph there. Next, sketch the graph of the following functions by transformations. Transformation technique, y equals 2 over square root of x plus 1, and y equals absolute value of cosine of x. So we relate it to y equals 2 over square root of x, where the y-axis is the asymptote, and the graph looks like y equals 2 over x first. So the asymptote should be the x and the y-axis, and the graph looks as shown, this blue dash curve. For y equals 2 over x plus 1, all you have to do is shift the graph 1 unit to the left, or shift the y-axis 1 unit to the left. So the graph would be, the asymptote would be this x equals negative 1. That's y equals
2 over x. This is the vertical asymptote, x equals -1. And the new graph of y equals 2 over x plus 1 is represented by this pair of two red curves. So that would now be the graph of y equals 2 over quantity x plus 1. For y equals absolute value of cosine of x, so it means that the negative values of cosine, like when x is negative uh, pi, it is -1. So let's have the graph of y equals cosine x first. It is 1 when x is 0. Negative pi, it is -1. Positive pi, it is -1. And 2 pi, 1, 0, 1. Cosine 0 is 1. Cosine of -2 pi, 1 again. So absolute value, meaning to say all these negative values of the portion of the graph of y equals cosine x would now be positive because we have absolute value of cosine x. So it will now look like as shown in the figure, those red lines. So don't mind about this part here, although it does not coincide with the graph of y equals cosine x. It's because I just sketched the curve by point plotting and using a curve in PowerPoint. So that's the reason, but just concentrate, focus on these red curves. That's y equals absolute value of cosine of x. So to continue, how is the graph of y equals f of absolute value of x related to the graph of f? Sketch the graph of y equals sine absolute value of x. Sketch the graph of y equals square root of absolute value of x. So by our experience with the preceding slide, the portion of the graph y equals f of x, the portion of the graph to the right of the y-axis is simply reflected about the y-axis. So that's the relationship between the graph of the portion of the graph of y equals f of x to the right of the y-axis and this y equals f of absolute value of x. The portion of the graph to the right of the y-axis, the portion of the graph of y equals f of x to the right of the y-axis is reflected about the y-axis. So for instance, for y equals sine of x, so sine of 0, 0, so you're just familiar with the graph of sine x. So this is the portion of the graph of sine x which lies to the right of the y-axis. We're going to reflect this about the y-axis. So it should look like this. And that's the pair of graphs reflected about the y-axis would be the graph of y equals sine absolute value of x. So let's remove it. We have the red portion of the graph of sine. It is reflected about the y-axis. So it should look like that. So this is the graph of y equals sine absolute value of x. Then for y equals square root of absolute value of x, so remember y equals square root of x is a parabola, upper half of the parabola open to the right as shown. So that's y equals square root of x. Then for the graph of y equals square root of absolute value of x, all we have to do is we have this first pair and the other pair would be the reflection about the y-axis of this curve. So let's remove it and let's have now the two curves reflected about the y-axis. So this is y equals square root of absolute value of x. So that's it for this video. I hope that you learned new things in calculus.